welcome to AIoTHub. I'm Paul Wheels, and I'm very pleased to see you tonight. Thanks so much for joining us. We've got a great show. We've got John Staveley, who is up in Scotland. Hi, John. How are you doing?
Yeah, all good. Thanks. Just been on a quick trip, canoeing down the River Spey. Went into a couple of distilleries along the way. Grade 1 and 2 rapids the whole way. Exhausting, but really stunning area. Really, really beautiful.
So were you hitting the whiskey and then getting back on the boat?
Small amount of whiskey. A wee dram, Paul. A wee dram.
A wee dram. We've got a great show tonight. We've got Simon Prickett on with us tonight. Hi, Simon. How are you doing?
Hello. Very well, thanks. I'm down here in Nottingham where it's, quite sunny today. So hopefully that stays the same and we get a nice evening.
It's a rare occurrence this summer, to be quite honest. The summer I think we had a one solid week, and then it's very intermittent. We've had rain and all sorts already today here up in Northumberland. So yeah, we could do with a better summer than what we're getting at the moment. So Simon, do you want to introduce yourself and tell everybody about yourself?
Sure. So yeah, my name's Simon Prickett. You can find me at the Let's Try Pointing at Things Twitter handle. There is probably the best place to look me up. I work for a company called CrateDB, which is a database company. It's kind of suited to IoT applications, which is what we are going to talk about here. And today we're going to look at a project that I've sort of been playing around with for just personal interest reasons. That becomes quite an interesting data problem and also a fun data source that you can mine. So we're going to be pulling radio messages from aircraft, receiving them with software-defined radio, and then trying to make some sense of them. And hopefully towards the end of the demo, we can then start to determine that interesting events have happened and trigger a display to notify us of those things. So what I always wanted with this system was to build myself something that when like a unusual or interesting aircraft goes by, so like say a 747 or an A380 or something just out of the ordinary, I get notified. And I love single purpose displays. So I went out and bought this thing, which is behind me. It's the display from a bus. It's the destination display. And each one of these is an electromagnet, and it can flip from a dark side to a highly fluorescent side. So towards the end of the demo, the aim is to get aircraft information that has been picked up from a radio that is over there. That's my aerial. And all the way through a database, through an MQTT server, to the sign behind us, so we can hear some nice flip dot electromagnetic noise.
I have to ask a question. How much did the sign cost? Because I'm really interested in getting one.
Okay, so eBay is your friend. This particular one was $112.50, which is seemingly quite reasonable.
Yeah.
And I kind of took a punt on buying it from a bus breaking yard. So eBay's now trying to sell me the rest of the bus, like all of the parts and like an actual bus. There is a company that has these as new old stock that costs a little bit more, which is a little less risky.
Yeah.
And there are some complications with using these. So this talk isn't about how to get this thing to work. I have another whole one that talks about the protocol and how that works. Go find me on YouTube for that, or if I get a moment, I'll post it in the comments.
Yeah, if you drop it in the private chat, then I can share it into the comments and browsers and stuff like that.
Have you got an interesting personal project you're working on there, Paul?
I haven't, and however, I had a bit of a brainwave idea of something I'd like to let people know when people are home and when they're not home in this house, and having that in the hallway. However, I'm quite confident that it will not go with the deco in this house, and the missus will block me from doing it. But I think it would be quite an interesting thing to be able to ping messages of locations of different family members onto that sign. We've got Richard Tasker online with us. Hi, Richard. How are you doing? Great to have you online. Thanks very much. If anyone else is here, please do say hello. If you have any questions, please do fire them into the chat, and we'll ask Simon when we can at the end. Simon, I'm going to hand over to you. This sounds like a great, innovative talk, so looking forward to hearing.
Okay, let's. If we could just share the desktop, I will. There we go. Some slides. This is going to be a little bit of theory and then hopefully quite a lot of actual practice. And the aim here is we're going to start with absolutely nothing and see what we can pull out of the air and make sense of. So we're going to go plane spotting. So what does that mean? You might have seen out there on the web, there's various plane tracking websites. So this is Radarbox. It's showing us traffic in real time. We can see all of the aircraft. We can see their positions. We can click on one. So I have EK19 here. It's a Emirates A380 that was going to Manchester. And all of this data is largely crowdsourced. So they have people that put devices out in the world, so all around the country, and they receive messages from the aircraft, send them into these aggregator sites, and then they offer web products. So I'm not a member of this, so I get the sort of ad-infused environment. And if we switch to Flight Radar, which is another version of this, here's another A380 down at Heathrow, you'll see similar. I also get the ads. So I'm not really that interested in putting these things just on a map and being able to drill into them. I wanted to do some other things with them. So I wanted to see how you could get this data for yourself and do something more, well, not necessarily more interesting with it, but just something different than what these folks are doing. So here's Flight Aware, which is the third option for that. Again, they're showing information about, I've got a single flight here. So these services are out there. We're going to take a look a little bit at what's powering them and how we can do it ourselves. So there's a thing called ADS-B, or the long name, Automatic Dependent Surveillance Broadcast. This is a standard, and planes that are of any size are required to have it. So anything commercial is going to have some sort of transponder that broadcasts these messages out. And generally, the messages are going to contain a unique transponder ID or aircraft address. So something that uniquely identifies that particular aircraft. A call sign, which might give us a hint as to what flight number it's operating on at the moment, or what air traffic control is referring to it at the moment. And a position, where it is in the world, and an altitude. These messages don't contain all of that information at once. So we have to listen for lots and lots of these messages and build up a picture over a sort of time series of messages that we receive. If we wanted to work with one of these Flight Aware or Radarbox or the other ones, and we wanted to send them data, we can actually go ahead and just buy a unit from them. So you don't have to build anything to take part in this whole system. Generally, what's going to be inside that unit, you can probably see the one on the top left there looks dubiously like a Raspberry Pi because it is inside. The one at the bottom is also a Raspberry Pi. And Flight Aware also provide instructions for building your own with a Raspberry Pi. There's a bit of a common theme here. You don't actually need a Raspberry Pi to do this. And you don't need to have one of these kits. What these kits are generally set up for is being what's called a data feeder into one of these networks. So you buy a kit like this, and you install the aerial, and you run this all the time, and it sends data up to Flight Aware or Radarbox, whichever one you're working with. And generally what happens is, in return, they give you access to their premium product online. So you can log in and see things like historical flight data or just more information. So what we're going to do is kind of look at how to get the parts to build one of your own version of this, and how to take control of it and do something else rather than just feed data to someone else, which is valid and a lot of fun. It's just not what I wanted to do. So there's like a couple of things we're going to need hardware wise to make this work. We're going to need a slightly specialized software-defined radio. You can get a more general purpose one that you'll see sold as something called SDR-RTR or something like that. There's a standard like six-letter thing for them. But you can also buy ones that are more specifically for receiving these messages from the plane. So I've put some up over there on the left. These are USB sticks, so you don't actually need a Raspberry Pi for this. It's not something that's going to connect to the GPIOs or do anything crazy. It's just going to plug into USB. Then you need some software that understands how that works. And then on the other end, you've got a screw-in connector for an aerial. There's a couple of sorts of aerials you can get. I've put a big X over the one on the right. They might work well for some people. They're more sort of like car CB type small aerials, or the sort of aerials you see with taxis. They're magnetic and they have a bit of a coil, and they're, I don't know, probably about 12, 14 inches long. Those I've had absolutely awful results with in my situation, which is mounting the aerial inside the house, which is not ideal. The aerial that you see at the bottom, I've had much greater success with, the one that's a sort of longer pole. That one happens to come from Pomeroni. They're up in Sheffield, and they're a great place to get stuff from. I got mine off of eBay, but it's about the same sort of thing. So we're going to need some sort of USB thing and an aerial to connect to it. And for the purposes of this demo, I've actually got the USB thing plugged into the MacBook that I'm presenting from here. So I'm not using a Raspberry Pi for this. You don't have to. We're actually going to write some Node.js software. So basically anything that's got a USB-A socket and can run a Node.js runtime should work. So what are we going to attempt to build here? And by attempt to build, what am I actually doing in this talk? I've written the software beforehand, tested it a bit. We've got a completely empty database, so we've got no history of messages or flights. And we're basically going to look at how it works, set it running, and see what it can pull out of the air. So hopefully what we pull out of the air is flights passing by me here in Nottingham. I'm fairly near to East Midlands Airport. But I've got, with practice, about an 80-kilometer radius of the house. So we can generally pick up stuff that's heading towards Manchester, out by Lincoln, over towards Birmingham, and so on. So hopefully we'll see a fair range of aircraft. So once we've got our aerial and our USB software-defined radio stick, we need some software that reads the messages and decodes them, and we'll look at what format they're in. Then we kind of want to store them, so we should put them in a database, because on its own, the message doesn't tell us anything useful. It will tell us maybe one or two elements of what we want to know, like where the plane is or how high it is. But it's not in a single message going to tell us, I'm Ryanair 1234, and I'm at 34,000 feet, and I'm at this location on my way to East Midlands. We need to store lots of databases and store lots of messages and aggregate data out of those. So we're going to use a database for that. Then I didn't want to build a map, so I wanted something that tells me when something interesting goes over. So if a rare or different or larger plane goes over, I wanted to get an alert. So when a certain sort of sequence of events happen in the database, we want the alerter to kick off, and it's an IoT project. So I'm going to use MQTT and have it publish a message onto an MQTT broker. And once it's done that, that will go to anything that's interested in that message, subscribes to it, and can display it in its own sort of idiom. So that's where we're going to try and use the bus sign as a display. Now, I was interested in, I want to know where the plane is and how high it is. And I also want to know what sort of plane it is and where it's going. These messages that come from the plane only have what's called a call sign, which identifies usually the current flight number that the plane is on. What it doesn't do is tell us any of the other things. It's not going to tell us this is like a Virgin Atlantic A330 going from Manchester to Atlanta. We are going to need some other data source for that too. So once we've got a call sign from a plane, what we're going to do is look it up in an API. So we're going to use the Flight Aware API for this. And we're then going to mix that data with the radio data to determine if the plane's interesting. So if it's passing over me right now, if it's in a certain radius of me, and it's a certain type of aircraft that I've decided is interesting, then we're going to create that MQTT message, notify the front ends, and hopefully we'll get an alert and it will tell us what's going on. So with that in mind, we should probably actually start to do something. So first thing to look at is, what is the format of the message? The messages are fairly low level. They're actually in binary, and then you can decode them, and there's a structure to them. And as you might expect for IoT sort of type things, there is a sort of frame structure to that, and checksums and all sorts of bits and pieces. And there's good news here. We don't need to worry too much about how this works, because somebody else has figured it all out for us. So what we're going to do is use some decoding software that will read the messages coming in on the USB stick, decode them, and we'll look at how that works and how we can get that into, in this case, a Node.js program, but we could use any programming language. We could use Python, .NET, whatever really. So I'm going to just switch away from slides here and move to actually the terminal. So there's a few things that we're going to need. We're going to want to, first off, make this a bit bigger so everyone can see it. We're going to want to first decode the messages that come in from the radio. So there's a bit of software available for that. It's kind of a standalone server, and it's called dump 1090. So the 1090 comes from the megahertz that the messages are transmitted on. They're like 1090 messages. And this basically deals with talking to the software-defined radio that's plugged into my computer here. And we'll pull messages out, and we'll start to show some information about them. So if we go ahead and run this, and this is like free software from GitHub that a lot of these solutions are built on. So it found my device that's plugged in, and it's already talking to things out there in the sky. So there's nothing to do with the internet happening here. All of this data is coming from the radio aerial that's in my window, which is behind me. So we've already seen, I don't know, quite a lot of messages here. Some aircraft have already sent us 250 messages. And we've started to find the call signs here. So we can see RYR9WN, that's probably a Ryanair plane. I happen to know these SHT ones are British Airways shuttle ones that usually go between Manchester, Scotland, and London. And we're starting to build up a picture of what's going on with the planes. So we've got quite a lot happening out there. But this software here doesn't really help us with integrating that into software of our own. What it does do is, once it's decoded these messages, it outputs them on a port that we can listen to. So if we go over here and start another terminal, so we can have a listen on this port with Netcat. So 0.0.1, and it's 3200. How many zeros? Let's see. In my crib notes, 3202. So dump 1090 here is doing one level of receiving the messages. Oops. Sorry, 30002. There we go. Dump 1090 is doing one level of receiving the messages, and they can be decoded into this format, which is not in itself that useful. This is still not a readable format that we know what's happening here. But on 30003, it can do some more decoding work for us. And we're now starting to get something that looks like a text format. So each one of these lines is an individual message. You can see here, this is the message. It's a message type 3. This one's got, everything's going to have the plane's call sign in it. So the plane's ID in it. And this one's got the lat long position of where the plane is. This one looks like it's probably an altitude in a message type 5, and so on. So we're starting to see what's going on with these messages. These again, fairly low level message encoding. They're not really that friendly for the application developer. So I'm an application developer. Ideally, what I see here as somebody who works with, say, Node.js a lot is it would be nice if this could be an event emitting stream. So I could write something that listens for events, turns them into something useful, like maybe a JavaScript object with data in it that I can use, and then goes ahead and lets me use that. Again, fortunately, someone's beaten us to that. And if we have a look at here, there's a nice module here on NPM that does this for us. So this is exactly what we want. We want to take the port 30003 format that this thing outputs and turn it into something useful. So as you can see here, this takes this sort of stuff, and I don't know if they've got an output. Yeah, it parses it out into JavaScript objects that contain useful fields. So stuff about where the plane is, what its transponder ID is, what its call sign is, and so on. Latitude and longitude, some other information that we're not too interested in. So with all of this together, we can start to write some software that now is going to receive messages. So I need to leave my dump 1090 here running because that's going to be our data source now. Essentially, it's pulling things from the air and it's exposing stuff onto a port. And I've got some software that is going to receive those and work with them. So let me just move to here. So there's a few things going on here, but basically we are going to launch what is called here an SBS1 client. So this is the module that decodes the messages into something sensible for us. It attaches to a host and a port. So that's going to be my local host and 3003. And then we've got some other stuff that we'll skip over for the minute. And we've now got this nice interface, which is kind of what we wanted. So we've got the ability to listen for a message that comes in from the radio and has been decoded by the software stack that we've got going on now. And then we can start to actually work with the message. You know, it has fields like what's the hex identity of the plane. So it's actual ID and latitude and longitude. And we can start to do something with those. So what I'm going to do with them is write them into a database so that we can start a time series of all of these messages, do something useful with them. We need them in a database because, as we'll see in a minute, the individual message is quite sparse. It's missing a lot of the data. So on its own, it has very low informational value. But if you start to aggregate them up together, we can build something that has a much higher informational value. Now, I'm going to use, database-wise, I'm going to use CrateDB here, which is a multi-model database that is good for IoT stuff. We are going to use a couple of features of this. We're going to use the ability to ingest data really, really quickly. We're going to use a relational-like table, and we're going to use a flexible object. So you can basically click here, get started, and I'm going to use the cloud. It's free, so you can start here and use that. You could also pull this into Docker and run it locally if you wanted to. So I have been and already set up a cloud database. So that's got an endpoint in the cloud that we're going to need later. It's got a host and a port and a username and a password that we're going to need. But for now, let's just click view here and go to the console. So we have an online database console here. I can write SQL queries. I already went ahead before the talk and made some tables in here. And what we're going to do is do that whole thing. If there's nothing up my sleeves, we've really got an empty database. So over here in a schema called plane spotting, I've got 3 tables. I've got flights, radio messages, and interesting aircraft that we'll come to later. If we have a look at radio messages, the structure of that is we're storing the plane's identity, call sign for the flight, altitude, and some other bits and bobs, the latitude and longitude, and a timestamp for when did we see it. I'm also storing a day of the year that we saw it on so that I can manage my data. A few days' time, these records won't be that interesting. I might want to delete that day's worth of records. And CrateDB petitions tables for us. So I've told it to petition them on that field. So we can just delete a whole petition and it'll be a fairly performant operation. So looking here, I've got a query. It's going to return absolutely nothing. So we've got an empty database. We've not pulled any messages into this. So we're not using any old data. This is a totally live demo. And you'll see here we just have all fields and nothing in them. In the other table, we've got that I've called flights. Again, we've got absolutely nothing. This is going to contain the information that we need to go to that API for. So we have to go to FlightAware and say, where's this plane coming from and to, and what sort of plane is it? Because that's not in the radio messaging. Then we're going to store that result in here so we can do queries and aggregations over it. And also so we can save ourselves some money. FlightAware's API costs a bit of money to call it. If we call it too much, we'll hit the rate limit and my credit card gets charged. But if we call it a few times and are careful about it, we can literally fly under the limit and not be costing ourselves money. So first thing we need to do is really turn this around, and we've got an empty table here. We need to put some data into there so we can actually do something with it. So if I flip back to VS Code, what we've got here is some pretty simple code that's going to store that data in the CrateDB database. And I'm doing that using the Postgres driver for Node. Why might I be doing that? Because CrateDB is wire compatible with Postgres. So we don't have to learn very much to start using it. We can just go ahead and use the Postgres tooling. I'm also using a small object mapping library called Squel that just allows me to build a JavaScript object and save it into a table a little bit more easily. So we're going to connect to CrateDB here. It's just the same as you would with Postgres. It's actually a Postgres URL because we're using the Postgres driver. And every time we get one of these messages, we're going to look for some fields. So we're going to look for the latitude and longitude, which might be there. We're going to look for the altitude, which might be there, the call sign, and squawk, which is a sort of indication of what's going on with the flight. You might have heard of something called squawking 7700, which is the plane's in an emergency. So it might be interesting at some point in this project to basically, when you see a 7700 in this field, send an alert immediately, no matter what type of plane it is. Tell me there's something having an emergency. But generally, we build up a little object here that contains any of these values that exist in the message. And then if we've got any of them, we just use the Squel object relational mapper to say insert it into the radio messages table, which is in our cloud database, and go ahead and run that query. So every time we receive a message, we're going to run a query and write it into the database. So let's go back to database is empty. Dump 1090 is decoding messages for us. So what we need to do is go to the right place here, is start that code running. And what we should see is, there we go, it started to receive messages. So what's happening is this fella over here, dump 1090, is dealing with the software-defined radio. Every time it gets a message, it's logging it into its own history and publishing it to a port. We are now then listening on that port and receiving messages in our Node application, and we're writing them to the database when they contain interesting and useful things. So hopefully, if we go over here, we now have data in our database. So we are now sending this stuff that we've captured offline to an online data source in the cloud. And you'll see we've already got 813 rows in the database. The other thing that you'll notice is a lot of these are null values. So as I was saying, the messages are quite sparse. There's only enough room for certain things in each of them. So we have to build up a picture over time. So if we pick a plane like, I don't know, 440640, so that's its transponder ID. And we do something like where plane ID equals that, and then order by timestamp descending, so get them in reverse time order. We can see everything that this plane has already communicated to us. And you'll see it's given us a position. A lot of what it's been doing is just telling us about its altitude. And do we have a call sign for it yet? No, we don't. Let's have a look at something else. Let's do where call sign is not null. Let's see what we've got here. So we've started to get some call signs in. So some planes have eventually transmitted to us their call sign or their flight that they're on. So we've now got enough information about some of these to actually go out to a third-party API and say, hey, what can you tell me about, I don't know, let's pick one at semi-random. So BAW99. So one way we can find out about BAW99 would be going to FlightAware. And in here, we should just be able to paste in BAW99. And it will tell us, okay, this is a British Airways flight. It's off to Toronto Pearson, and it's somewhere within the range of my aerial at the moment. And what else do we know about this? Okay, it's an A350. So this is all interesting information that I want to capture that isn't available from the radio messages. But the key to getting it is this call sign that we got from the radio message. So what we need to do is figure out when we get a call sign and enough information to determine where the plane is. So we've had a call sign and a lat long from it. Then we will want to look up in FlightAware what this call sign means, get some information back, and store it in our flights table, which is currently empty. So let's just again run this. And while I've been talking, we're now up to 5,948 messages received from aircraft. And counting. So even while I had a drink, now we're up to 6,238. So there's a lot of stuff coming out of the air towards us right now. What we need to do next is look at a couple of things. So some of these planes are going to pass by and we're not going to get all of the information we need. We might never get a call sign or a position. So we only want to know about ones where we've had all of that information and fairly recently before we go and make this expensive API call to FlightAware to say, tell me what sort of plane it is and where it's going to and from. And to do that, I've got a SQL query that will put into another component, but I'm just going to paste it in there for the minute because it's quite a long one. It would be good if I copied and pasted it, didn't delete it. So we're going to paste this in here, and basically what this is saying is find me the plane that has, or the planes that have the call sign and the lat long and everything else we're interested in and that we've heard from in the last 2 minutes. So if I run this, this will tell us basically a better picture of what we've seen about this plane. So we've seen, if you take these ones here, the EZY ones, they're EasyJet. You'll see that it last spoke to us quite recently. It's at 19,725 feet as far as we know. I've had the database calculate how far away it is from me. And here's its position, the lat long. So all of these planes here sort of qualify for, yeah, we should look them up on FlightAware because we've got enough information about them. So we should look them up and see what sort of aircraft it is and where it's going to. So in order to do that, I wrote a second little component that we've called the processor here, also in Node.js, but again, could be in anything. And I'm going to skip over a lot of what the code here does, but basically, again, it's connecting to CrateDB. It's using Postgres to do that. It's ultimately going to talk to an MQTT. So we need some MQTT library. And what's going to happen is, let's just scoot down here. It's going to run that query that I just ran and ask the database, hey, what are all the planes that most recently have all of the data that we need for? And I put a limit 1 on here. So it's just going to return the latest one. And it's then going to sit in a loop, call all of these, this SQL query, and get the plane back. See if we've previously looked up the information from it. So does it already exist in this flights table? Flights table's empty at the minute, so the answer is going to be no. If it did already exist, we use the cached information about what the plane is because we don't need to look it up again. And if we hadn't got it before, we will go ahead and look it up on FlightAware's API that we do need a key for. You can subscribe to this API, and you need to give them a payment mechanism. But at the level at which I'm using it, it never gets, you never get paid for. We never have to pay. And basically, once we found the flight, we're just going to insert it into the database here. So we'll just do a regular insert statement, similar to most other SQL databases that you might be familiar with. And we'll not worry about what else this does at the minute. We'll just start this running. So if I have this running and I need a new window, we end up with a lot of terminal processes here. So processor, I'm going to start running that processor. So what it's going to do is start looking up flights that look interesting. So I actually found BAW99, that flight to, I think it was Toronto Pearson, and it's gone away and looked it up in FlightAware, and we've stored some details in our database now. So we now know from a combination of the API and what we pulled out of the air that BA99 is operated by GXWBA, which is an A350-1000. It came out of Heathrow. It's going to Toronto, and it is, yeah, I think that's Toronto. And it is at an altitude of 26,800 feet. This component's gone to sleep for a bit, and it'll come back and periodically check to see if there's new flights that we need information for. So how does this get stored? Let's get rid of this big query, and let's see what's in our flights table now. Planespotting.flights. So here you can now see we've got a couple of flights that it's determined we had enough information for since we started running it. And I don't really know what the shape of that API response is going to be. So I've used a CrateDB feature here. We've got an object column, and by default, objects are dynamic. So I can store arbitrary JSON structure in them. It's going to index all of this as well, so we can write queries that involve any of these fields without having to go back and change the database index. So you can see the raw information that came back from FlightAware. We get all sorts of stuff about this. We get the operator, so BAW is British Airways. We even get which gate it originated at Heathrow and all of this stuff. So having got that, what we really want is, let's see if we can do a select flight info aircraft type. So there's a field in that response called aircraft type, and you can see that maps to an aircraft code. So A35K is an A350-1000, B738 is a 737-800. And if you remember, what I wanted from this system was to let me know when something interesting was going past. So I would say the 737-800, not an interesting type of aircraft, just because it's really, really common. Whereas the A35-1000, that's pretty large. They don't pass over here all that often. And it would be nice to get an alert for that, so we could run outside and go, oh yeah, look, there's an A350 and it's off to Toronto or wherever it's going. So once we've got this sort of thing going, we then need to write some code that does that alert for us. So back here in our processor component, we have some code that was inserting things into the database. And then when it's done, we have to figure out if it's interesting. So what we do here is we run a query with that aircraft type value that we got back from FlightAware, so A35K or B738. And we run that against a table that just contains interesting aircraft types. So if I copy this and run it into here and change the thing here, so is an A35K interesting according to our table? Yes, it is, because there's some data in the lookup table for it. So in our interesting aircraft table, we have two fields, and I just pre-populated this one because it's reference data. I've got an aircraft type, so the code for that, and I've got a description, so something that we want to show on a sign. So A35K gets expanded out to A350-1000, which is what people know it as. Let's try another type of aircraft, so the smaller A319. We don't get anything back for that because I didn't set it up in the table. So basically that says I'm not really interested in an A319 when it goes over. Don't bother me with that. So what I'm going to do is just change my code a little bit here, because if something interesting happens, if we get a row back from the database, if the flight's determined to be interesting, we're going to pull together some information from the flight API record in the database and the radio messages records in the database and figure out what we want to put on our front end notification service. So I'm sending in the flight number and the registration and the aircraft type and where it came from and where it came to and how high it's flying. And then down here, I've got some code that's commented out. Comment that back in again. What it's going to do is just push these alerts out to an MQTT client. So this doesn't know what front ends we've got. It doesn't care. It just puts them on an MQTT topic, and then something else can pick it up and display it. So save that. And if I restart this, let's first just go back to plane spotting.radio messages. So let's see what we're up to now. So 23,830 messages received during the course of this talk so far. So what I need to do is stop this component here because we changed it to now do MQTT publishing. And what you'll see is off it goes. And the first thing it found that's going past is an A380 to Manchester from Dubai. So that looks like EK. It's an Emirates one. And it went ahead and triggered an alert on our alerting system. So I've got an MQTT broker and a way of viewing that here. The broker is, let's get this started up. The broker is on the other screen. There we go. So we'll connect to this. And you'll see, where are we? Okay, I should be seeing messages. Oh no, what's happened? Let's just disconnect and reconnect. Why are we not seeing messages in here? Okay, well, we'll press on and see. So this should be publishing things to our MQTT topic, and we should be able to see them here. Unless I'm, nope. Okay, so we'll carry on. We might get messages to the site at this point. So I'm going to quit that and see what happens with it. So we should be building up messages on the MQTT that we can't see because the reader application isn't working for us. So the next step of this is to actually display it on the sign behind me. So hopefully, if things are working, every time this creates an alert, then it'll start to display stuff on the sign behind me. And in order to do that, I need to go to yet another terminal. And this terminal here is actually running on a Raspberry Pi. There's a Raspberry Pi in the back of this sign here. And hopefully, when we start to run this component, it might actually start to do something if things were getting onto the MQTT. Yep, there it goes. Maybe. Oh no, it's just setting itself up to wait for things. So I have got an MQTT problem, it would seem. So what we're going to do is go back to here and I've got a plain spotting connection. Yep, that looks like the right. No, it's working. So for some reason, MQTT has kicked in again. Let's blame Hive MQTT in the cloud for that. But what you'll see is happening is every time this creates an alert here, the big sign behind me is going to go berserk. So every time we've got a plane that has sent us enough messages that we know where it is, and we've put some things from the API into the database, and we've decided it's one of our planes that is interesting from the database, then we send an alert. So this one here triggered one, and this sleeps for about a minute. We can actually speed that up, but about every minute, it's going to check for interesting aircraft that are talking to us. And here's one, for example, that isn't. So the most recent aircraft that met the criteria was an A319. It's not interesting because it's not in the table, so no alert. So EasyJet, we're not interested in you. We didn't really look at how the code for that component works whilst I was trying to figure out what was going on with my MQTT. But as you might expect, it's a fairly standard MQTT subscriber. So there's some specifics in here to deal with the flip dot display behind me. That is kind of complicated hardware, and that's a talk in its own right. But what's happening is there's a lot of stuff here to do with the flip dot. We just listen to a particular topic on the MQTT. So I've got all of that configurable. And every time we get a message on that topic, here we go. Every time we get a message on that topic, we just parse out the JSON that the other component put in there and send it to the display to be rendered. So this display could be anything. It could be an e-ink display. It could be the thing behind me and so on. So I'm going to see if I can speed this up a second and get it to generate more alerts just so that we can all enjoy the sign a little bit. So I'm going to change this thing's sleep interval to 20 seconds and run it again. So there we go. It's found a Leeds Bradford flight now. So I'll leave that running and it will make some interesting noise in the background. But what we've essentially built in well, I haven't coded it in 45 minutes, but what we've enabled from an empty database is we've now got all of this stuff going on. I'm actually going to turn that off. Let's slow it down. There we go. What we've enabled from an empty database is we've now received, 35,890 messages. We've now got this whole time series of stuff. And we've got one front end interface to it, which is a sign, which is quite a proprietary interface. A more common thing to want to do with this, let me start some things again, but not the sign. So let's just turn off the noisy sign for a second. There you go. A more common thing we might want to do when we've got a database and we've got data in is build a visualization out of it. And I said earlier that CrateDB here is Postgres wire compatible. So it works with a lot of tools. So I was able to build a Grafana database here, a Grafana dashboard here. And if we go launch this, hopefully what we'll see is another way of looking at this data from what was an empty database. So I'm going to start the plane spotting thing. And what we've got here, let's just make it a little bit bigger, is some widgets. So this is standard Grafana stuff. Every one of these is just powered by a SQL query. So how many messages did we receive over the course of this talk? And that should be auto-refreshing. And what is the average altitude of planes that we've seen over the course of this talk? What sort of planes have we seen? So we've seen 37800. We've seen that's a 737 MAX. That's an A350, A380. Who are the most common operators of the planes? So we've got a couple of Ryanairs there. We've got a couple of U2s, EasyJet. And then for fun, I put a map on here. And this map is showing, we can look at the SQL query for this. This map is showing the last 1,000 messages that had lat and long positions on it. So it's a rolling map of just where the planes are going. So if I just bring that back, you'll start to see the range of this software-defined radio with a relatively small aerial in an awful position in a window. It's pretty impressive. So I'm here in somewhere in Nottingham city centre, and you can start to see that we're reaching things all the way out over here, sort of towards Skegness, and as far west as where have we got here? Somewhere near Oswestry, Market Drayton, Sheffield, maybe a little bit further. We got one right on the coast there beyond Manchester. And you can see that these are individual planes. So as they pass by, you can see the frequency with which they're talking to us as it passes in a line from, in this case, sort of somewhere north of Nottingham to sort of Clown, which is towards the Sheffield area. So yeah, that was really my talk. I would encourage you to get interested in this sort of thing because it's not hugely expensive to do. The decoders are about 30 to 50 pounds. The aerials are kind of as little or as much as you want to spend, or there's tutorials on how to make your own. All of the software components are free. I'm using the FlightAware API to get this extra information about, I wanted to know what sort of aircraft it is, and so on. And even that you don't get charged for at the level at which I'm using it. You would have to be hitting it very, very hard and without any caching to incur charges. So yeah, that was about it. I've got a couple of things for. Let's go back to slideshow mode, and I've got a couple of things for people to take away. If you're interested in learning more about CrateDB, there's two ways you can do that. Go to learn.cratedb.com and take a course. We have a course about time series at the moment. Or get a hold of me on Twitter at Simon_Prickett. Those are my sort of calls to action. If I can ask you to do one thing, if you've enjoyed this talk, it would be go and take the course.
Thanks, Simon. That was absolutely brilliant. What, taking consideration with the planes, what other things could people use the basics of this to track other things or connect with other things?
So I believe you can do similar with ships, but as you can probably see, for people who aren't that familiar with UK geography, I would have a little problem with that because I am like smack in the middle of the country, far away from any sort of meaningful shipping.
Yeah.
I think with similar hardware, so the more sort of generic SDL RTR ones, you can also potentially do stuff with data sources like, I don't want to say police radio, but there's like weather and some other things that are sort of generally broadcast for public service purposes.
Yeah.
You can also listen to ham radio and decode digital data like pager data, and listen to airband, which is like the frequency that aircraft talk to each other on. So get some audio between the pilots.
Yeah, but this was really of interest to me because it's a couple of things. It makes for an interesting data set to play with, especially when you start mixing it with other things like API data from this, or you could add in I don't know, weather data and then start to plot weather. But I really just wanted to build this thing for my own personal satisfaction, that whenever like a large aircraft goes over, something that's noisy and like a glanceable display goes nuts, because I'm still that person that will go outside and go look at it.
Yeah. Looks like there's a lot of engineering there. Bruno Dave is asking, what range do you get from your antenna?
Yeah, so we get let's see. So in this demo, we got as far as Hunstanton in one way. That looks pretty good one. So what we can do is I the measuring facility on Google Maps. So I'm about here. Oops. And if we do measure distance to, let's see, so Hunstanton's over here, right? Oh, look at that, dead on 100 kilometers today. So I would say that's a little bit better than normal. Normally, I would anticipate getting about 80. So I'd normally anticipate to see to around like Sleaford, Boston, maybe.
Is that dependent on weather, or whether you've got it on top of your house or not? Or
it's dependent, I think, on mostly position, but potentially things like reflections. My aerial is not in a good position because I don't own this house, so I can't go and put the thing on the chimney. It's hanging in the window, and next door's house is kind of close to us, so there's potentially a blind spot in my aerial. But when I can, I kind of intend to do something with a more permanent aerial, and then plug the software-defined radio into a Raspberry Pi and just like leave it up in the loft in the house somewhere, connected to an aerial outside of the house, and just leave this thing running all the time.
One thing I wasn't clear on is the MQTT piece didn't work, but you were still getting displays on the board behind you. So what was the MQTT?
I think that's this software's a bit buggy because it is working. You can see it here now, but it wasn't. What I wanted to do was show this, arriving on the MQTT and then show a consumer dealing with it. For some reason,
like the feed into the board.
Yeah, so that's the feed into the board. So you can basically send it any object that looks like this, and it knows what to do with it. How does the board actually operate, and how do we get to write Node.js code for it? That's like an hour's talk in its own. But basically, the board is it's a 84x7 matrix of flip dots. So they each have a bright side that you see here, and they each have a dark side. And let's just turn it back on again. We occasionally get some bad messages that this doesn't like. If we just turn this back on again, it'll eventually go off and do something. And what happens is you form up an image, if you like, of all the bits of the board and send it to the board, and it changes all the magnets around. So it's very noisy, and it is there's one. It's extremely satisfying because it's one of those glanceable displays of it's silent when it's doing nothing, and then when it does do something, it must be something important, because that's what we what we designed it for. I'm slowly also working on
the
getting
aerial
it to
you've
play
got.
tracking.
Is that general use, the aerial, or is it just for the frequencies that aircraft transmit on?
So the aerial, I'll just go back to this because it's more interesting. The aerial is optimized for the plane use case, and there we go again.
And I'm going to listen to FM radio on it.
No, you wouldn't. And also the USB stick that I've got is optimized for the plane use case. With the more generic SDL RTR ones, you can get filters that you shove on the end between the aerial and the device that are for different purposes. So you might get one that is for 1090 messaging, and you might get one for other things. So I just bought one that had the filter and the USB built into the same thing because I knew I was basically going to do plane tracking because I didn't really have a use case for anything else.
Sure, yeah. And how much was it all together?
I think the plane tracking stick was about £50. The aerial was probably about £30. There's a guy on eBay sells them in various lengths and basically makes them outdoors proof. But at the end of the day, it's just a piece of the right sort of wire wound around something at the right sort of rate to attract the right sort of signals, if you like. As I understand it, you can make them yourselves very cheaply, and people do build like huge ones that they just lay out on the roof of their house.
Great stuff. Thanks for that, Simon. That's fabulous.
Absolutely brilliant. Really enjoyed that, Simon. Thanks very much. We've got the website on there.
I'm really pleased to see all the demos worked.
Yeah, I will also. This is all like open source stuff, so I will tidy it up a little bit, and I will turn off the noisy sign. I'll tidy it up a little bit and share that. So software-wise, all of this stuff is open source. It's once you get to grips with what the moving parts are, it's fairly easy to start to distill this into JavaScript objects or Python dictionaries or whatever you want to work with, and then kind of like whatever you're interested in doing, you can then put it in wherever you want it to go.
Excellent. Thanks, Simon. Yeah, share us the link and we'll get that shared out with everybody as well. Really appreciate that. We're taking a break for the summer across August, so there won't be one on show in August. But we're back in September with an in-person event at Newcastle, which we'll share, which is with the National Edge AI Hub, our sponsors. Charles is online watching the show tonight. And then we will get back to October, where we will have a live stream. We'll be doing the in-person live stream in that as well. And then usual live stream in October, and then we'll have an in-person event in London, all being well, in November. That's right, isn't it, John?
I think so.
November. Yeah, I think so. So watch this space. If you're not registered on the website, register on the website. You'll get all the updates. Follow us on LinkedIn as well. And thanks very much for joining us. Simon, great to have you. Absolute pleasure meeting you and a great talk. Thoroughly enjoyed that.
Thanks very much. And yeah, if anyone's got any questions, find me on Twitter. I'm getting used to pointing at things backwards because everything's reversed.
Is it that one or that way? That way. Right, brilliant. Thanks, guys, and good night.